My guest today is David Dilley.
Thank you, Tom, for having me on again. It's a pleasure to be here. I'm a former meteorologist, NOAA, National Weather Service, United States Air Force. Currently, senior researcher, meteorologist-climatologist at Global Weather Oscillations, Incorporated. 50 years of experience in meteorology and climatology. So I'm going to be able to show you a few things. And working partner with the International Hurricane Protection Association. I have developed what we call ClimatePulse Technology. I'm going to show you a little bit about that. It is proven science, and we're going to take a look at the Milankovitch cycles, which is proven cycles for climate, and the subset cycles that I have looked at. It is essentially the electromagnetic interactions between the Earth, Moon, Sun. Everything in the universe and Earth is electromagnetic. Specialize in hurricane landfall predictions. We predict the landfalls where they're going to occur 6 months before the season even begins, and we have about a 90% accuracy. El Nino forecast going out 2 years in advance, climate change and weather cycles, all based on our ClimatePulse technology. And I have videos on YouTube on various aspects of the climate, and we're going to touch on some of it today. But if you look on YouTube, Google my name, or on our website in the climate section, we have some videos. First of all, global warming. What is global warming? Where does it come from? Let's just touch on it quickly. Global warming begins in the Arctic and Antarctic. About a 230-year cycle, global warming comes back again. When it comes back, it takes about 20 years for it to hit its peak. It started in the 1990s, hit its peak this past year. So global warming, what happens is the Antarctic and Arctic warm up. And as it warms up, you have less cold air available to filter southward into the mid-latitudes, and it warms the mid-latitudes. That is global warming. Well, global cooling also begins at the two poles. In 2022, the Arctic had the coldest spring and summer on record. Boy, can you have that during global warming? Coldest spring and summer on record. And I just checked what's going on up there now. And in April, they're again running below normal temperatures this year. So they'll probably have a cold spring, summer again. So the Arctic is cooling down. In 2021, the Antarctic had its coldest winter on record. Global warming, I'm telling you. So what happens? Okay, so we have cold air available, and that starts to filter southward, and eventually you have global cooling. It doesn't come on overnight. We get bits and pieces of it, like we did this winter, especially out on the West Coast. But it's like global warming. It takes about 15, 20 years for it to really get entrenched and hit its peak. So it's coming, and it's going to get worse and worse. Is the current global warming cycle, though, caused by the rise in atmospheric carbon dioxide since 1850? This is all we hear about. It's caused by carbon dioxide. Or is it natural cycles? And we're going to look at the two. First of all, carbon dioxide in the atmosphere during the past 800,000 years. What we can see over in the left-hand side, we can see the two approximate 230-year cycles where carbon dioxide rises and falls. Then way over in the right, carbon dioxide came up recently. During our historical data, it's never been above 300 parts per million, but that's in ice cores, and that's just an estimate. And it is underestimated by about 25%, the peak in carbon dioxide. And this is why when we see the peak of 413 now, way above that 300 level, that's why NOAA says, well, that's all caused by fossil fuel. No, it's because we underestimated the historical natural carbon dioxide. And all of this is detailed in Tom Nelson's podcast, number 64. Go back on that, and I detail everything about the carbon dioxide. And the findings were that since 1850, NOAA and IPCC says the rise in carbon dioxide is 100% fossil fuel. However, on the over on the right, in the green, my research using some peer-reviewed journal data and some of my own research shows that the rise is 80% natural. A peer-reviewed journal printed this past year by Scrabble et al. They are three physicists, and they found a formula that separates the various isotopes, and their findings, rise in carbon dioxide is 80% natural. And then peer-reviewed data on plant stomata, 80% natural. So it is 80% natural. We're at a natural cycle on carbon dioxide, and it did not cause global warming. So let's take a look at global warming caused by natural cycles. Well, let's take a look at that. What we're going to look at is the Earth-Moon-Sun interactions. It is proven science. You can Google it for whatever you want. Milankovitch cycles of the Earth-Moon-Sun interactions. Electromagnetic cycles. Essentially, this is what it is. The Earth goes around the sun in an elliptical path. Every 120,000 years, the Earth becomes closest to the sun. And then about 60,000 years later, it's the furthest approach from the sun, greater distance. So the bottom half of this is all ice age, very cold due to less sunshine and also the tilt in our axis. Our closest approach was 8,000 years ago. We were warmer 6,000 to 8,000 years ago than we were today. The reason was we were the closest approach to the sun and came out of an ice age. We're 8,000 years off the peak now. We're actually cooling down. And this is the cycles, the Milankovitch cycles, 120,000 year cycles, back 450,000 years ago, very warm. Then the Earth goes into a sleep pattern, then very warm into a sleep pattern, and so forth. And then here we are over on the right, very warm again. And this is just natural cycles. We're supposed to be this warm. Well, there are also shorter cycles than the 20,000 year cycles. We're going to take a look at there's 1 month cycles, 230 year cycles, 9 year cycles. And what brought me to this type of research, and I haven't shown this graphic in quite a while, back in 1948, bottom left here, 1948, Dr. Reed Bryson, he's considered the father of climatology. He did this graphic on the bottom where this is a 1 month where the moon goes to the north about 240 miles first half of the month, then it comes back down, then 30 days later it's up the highest, it travels northward in latitude again. So that's what he found. And what he found in top graphic, it moves the high pressure systems by about 230 miles. So he found this way back in 1948. I talked to him about 10 years ago and asked him, why did you not continue your research on this? And he said, peer pressure. I was new at the university and they said, get back to meteorology. So that was peer pressure. If he could have continued his work, we'd be way ahead on the natural cycles now. So I picked this up about 10 years ago and I've been working on it. This is what got me going. And we're going to look at some of these cycles. So on the shorter cycles, Here we have a moon, Earth, and at this point, the moon is at what we call the apogee, the furthest point or distance from the Earth. And then what happens is, get it moving here, it's also an elliptical path around the Earth, just like the Earth is an elliptical path around the sun. Wow, just the same, really. So we get the elliptical path, and when it comes in closest approach to the Earth, and this happens every month, that's your 1 month cycle. Then you have stronger cycles every 4 years, 9 years, 18 years, 70 years, 230 years, all kinds of cycles. So when it comes in closer to the Earth, the gravitational pull increases by 30 to 40%. That's a pretty good amount, 30 to 40%. That's why you have high tides. Once a month, you have a high tide. Well, if you had a period where the Earth, moon, and sun become in alignment, that's called a perigee-syzygy. The gravitational pull is increased by 44 to 47%. Now, wouldn't you think that would cause some effects on the Earth, on the position of high pressure systems? I showed you that on the Dr. Bryson graphic. And also, when you have these, you have coastal ocean flooding without even a storm in sight. That's because of the gravitational pull. And these cycles, as I said, you have a weaker cycle once a month, stronger cycle every 4 years, stronger every 9, 18 years, out to 70 and 230 years. This is what the cycle looks like. This is a 220-year cycle where it peaks, lessens, peaks every 230 years. That's covers about a 1,200-year span. Well, the 9-year cycle and 72-year cycles look just like this. Just like it. Now, this is the global warming cycles from today back to 800 AD. You can see we've had 2, 3, 4, 5, 6 global warming cycles. Natural. We didn't have automobiles back then. This is all natural. Now, let's take the gravitational cycle and overlay it on top of the global warming cycles. What do we see? They look the same. That is what causes our global warming cycles every 230 years. So, what has caused the Arctic to melt since 1990 to 2023? What caused it? Well, what happens is, this is the Arctic. Here is Great Britain, Ireland. Over on the left is Greenland. This is what we call the Ural Straits, and we have the Arctic Ocean. Every once in a while, we get a warm pulse of North Atlantic Ocean water to come into the Arctic Ocean. It takes about 11 years for it to circulate the ocean before it finally has cooled down and died off. The Arctic ice does not melt from the top down. It's not melted from warm air. It melts from the bottom up, from warmer water. And this is what does the melting. Now, we take the 9-year cycles, the gravitational cycles that I was showing you. These are 9-year cycles. This one's 8 years, sometimes it's just about 8 years between. Well, in 1990, we had a very warm pulse of North Atlantic Ocean water go into the Arctic. That started the meltdown in the Arctic. Then it took it 11 years to cool off. And just about the time it was cooled off, we had a very warm pulse in 1999. Right there. And look, both of these pulses, look where they are on the 9-year cycle. Right on it. And then we had another pulse right on the cycle, the gravitational cycle again, and that one will take about 11 years or so to cool down. That'd take it up through about 2017. And the pulses are now getting weaker, not as warm. So the oceans will start to freeze up again. And that's what we're seeing right now is the Arctic has run very cold last spring and summer, coldest on record. And it's below normal temperatures up there right now in April again. The warm water pulses are fading out. They'll come back again on the next global warming cycle, but we have to wait about 200 years. Okay, signals of global cooling. That is beginning. Well, we just talked a little bit about the Atlantic. Let's shift over to the Pacific Ocean, the North Pacific. This graphic in the gray and the red, this shows ocean water temperature cycles, the North Pacific ocean water temperatures, going back to, believe it or not, year 1500. That's a long time. So you can see the cycles where it warms up, cools down, warms up. The warm-up periods last between, these are about 30 years, 42 years, 40 years, 30 years, 15 years. And we're currently 42 years of a cycle. The longest two were 40 and 42 years. We're coming out of that warm water phase cycle. The North Pacific is going to cool down and stay cool for the next 30 years. And what does it mean? Well, warm water in the Atlantic and the Pacific causes ocean expansion. Sea level rises a little bit. That's part of the sea level rise. Well, when the ocean cools, it contracts and sea levels go down a little bit. And what we're going to do is look at this part right here on the right, especially on, are we going into a cool phase of the Pacific Ocean, and what does it mean? Top graphic is the ocean water temperatures, and I boxed off the North Pacific. The water temperatures, the yellow, orange, and red. Red is extremely warm water. Orange and red are well above normal ocean water temperatures. This is back in March of the year 2020, 4 years ago. We had just a little pocket of cool water in there. Well, what do we have now? As of March 15th, April 15th of this year, you can see how that cold water is expanding in the North Pacific. We are going into the cool phase of the Pacific Ocean. And you can see the cool water all the way up from Baja to California up to Alaska. And one thing that happened is back in end of January, the water cooled down. The La Nina that we had been in for 2 years stopped. It ended. So what happened is this caused the whole atmospheric circulation to change in the western United States. And we had record snows in California, just about record snows across the northern tier of the United States into Buffalo, megastorms. We're seeing a change in our atmospheric circulation due to the Pacific Ocean changing, due to the natural cycle of the ClimatePulse gravitational cycles. It is all coming together. Again, this is your global warming cycles, the 6 of them during the past 800 years. One thing I want you to notice is, go back to 900 AD, when that global warming cycle ended, the next global warming cycle ended about 200 years later. The next global warming cycle ended about 230 years later. The next one, 240. The next one, 230. And now, what is 230 years later? These are an average of about 230 years for a global warming cycle to end. So, what's 230 years? Well, the last one ended in 1794. Global warming cycle ended, went into a global cooling cycle, very bad global cooling cycle. So 1794, global warming ended. Add 230 years to it, year 2024. Everything is coming in. It's gelling. We are going into global cooling. Global warming. Remember this? We heard global warming ending the world in 12 years. Now we're down to about 8 years, maybe. We do not have much time left, according to some people. Well, is that going to happen? Well, actually, we're going to have an unexpected climate change disaster that a lot of people do not know about. We are going into global cooling, so don't worry about global warming ending the world. That's not going to happen. So what is going to happen? Here's the global warming cycles again, the 6 of them since the past 1,200 years. The yellow circles are historical strong volcanic eruptions. If you look back around 900 AD, it occurred as we came off a global warming cycle. And then we had the yellow one circled in red are the strongest one. This is what we call VEI 7, extremely historical one. This was actually occurred somewhat in the middle of the global warming cycle, but it caused probably a year of no summer. Then we had a couple in the next global cooling cycle, as we came down in global cooling cycle. And then the latest one was in 1815, VEI 7, Canberra in Indonesia. And we had a year of no summer in 1816 and 17. We had 1 billion people on Earth. We had crop failures around the world. There was killing frost. Every month of the summer from Maine to Virginia, ice on small ponds in Pennsylvania. They had yellow snow over in Europe, crop failures, potato failures, even northern China, rice failures. During 20, 30 years following that, about a third of Europe perished through civil unrest, disease. We had 1 billion people on Earth at that time. We have 8 billion people now. If over to the right, we have a historically big volcano again connected to the global cooling cycle. 8 billion people to feed. We will not be able to do it. This will be the biggest human disaster in history of the world. And these come, it's likely to come, it could come any day, or it could be about 15 to 20 years, but it's coming sometime during this period. If anyone would like to get a hold of me, easiest email to remember is davidgwo@aol.com. Website, easiest website to remember is globalweathercycles.com. And that will bring you over to our principal website, globalweatheroscillations.com. So you may contact me.
Super interesting. I have a lot of questions, actually. What do you think is the % chance that we're going to get one of these year without a summer type events between now and 2050?
I'd say it's up around 80%. When I looked at these, I think 4 out of 5 of the global cooling cycles had the big year without summer. So that's running right around 80%. So there's a high probability. And even if it's not as big as the 1815 volcano, if it's just a little bit smaller, it'd still be strong enough to cause the massive food shortages. With 8 billion people on Earth, you're going to be looking at massive civil unrest.
What should we as a society be doing to get ready for that?
Well, in the Bible, they tell you to store up food 7 years for 7 years of famine. And this is what everyone needs to do. You need some extra food on hand because if we have something like this, you're probably going to have a food shortage for a good 3 years.
Do you think we could grow food in greenhouses to keep 8 billion people alive?
Well, we could definitely, if we have enough heating resources, we could change a lot of the empty buildings over to greenhouses and set up indoor farms, during the cold winter. The only trouble is you'd have very short notice of it. The volcano comes on and bam, you're in this historically bad year of no summer. So you'd really have to gear up pretty fast. And the problem is, all we're talking about is global warming. Global warming is not the problem. It's a natural cycle anyway. Global cooling is by far more dangerous when we have so many people on Earth.
Do you think there was some sort of external thing that was happening that caused the year without a summer in 1816 to cause Tambora to erupt?
Well, just the gravitational pull. What happens is when you get these strong gravitational cycles, you get very, very strong cycles. You have the platonic plates around the Earth. So the gravitational cycles can, well, during the cycles, the Earth can bulge by about 1.4 kilometers. That's how strong the gravitational cycles are. So you cause a bulge in there with gravitational cycles. Then as it relaxes, you could get the plates to slip and bam, there's your earthquakes, there's your volcanoes. And this is why they're tied into these strong gravitational cycles.
Absent a big volcano, do you think we would see cooling between now and 2050 in like the UAH satellite data?
Oh, we're definitely going to have the cooling. I have the winter outlook for Europe and North America on our website now. It's for sale at a small price. But I talk about it, and I talk about a lot of the stuff that's going on. And with the Pacific cooling down, one thing we're going to see is every El Nino. We're coming into an El Nino this summer. That's where the Pacific waters along the equator warm up. And when that happens, that's opposite of the La Nina that we've had the past 2 years. We're now going into an El Nino. So that strip along the equator warms up, and that causes change in our atmospheric circulation. So what's happening, that in conjunction with the North Pacific cooling down, we're going to see a great change in our atmospheric circulations. Every El Nino from 1982 up to the past one and a couple of years ago were what we call warm El Ninos, where the United States pretty much ran warm during the winter. Prior to 1980, all the El Nino events caused a cool winter in the United States. I was surprised when I looked at that. I was always under thought that the El Nino caused a warm winter. But when I looked back historically, no. Historically, it causes cold winters. So with the North Pacific cooling down, the El Nino coming, we could be in for a very bad winter. And this and then tied in with the La Nina coming right after that. This is global cooling starting. It is starting. Each winter it will get progressively colder. This past winter, we had a small taste of the very cold winter. They had record temperatures up in the northeastern United States that had not been seen since the 1960s. That's in global warming. Even the coldest wind chill on record was recorded on Mount Washington in New Hampshire, and that's going back into the late 1800s. So the cold air is coming, and I showed you the Arctic and Antarctic cooling down. So it's all in place where each year we're going to get progressively colder and colder and colder. And probably within the next 5-6 years, we'll have temperatures much like we did in the 1950s and 60s, which are very cold. And then after that, we're even going to be colder than the 1950s and 60s. It's going to be very cold. And we're not prepared for it at all. We're going to have crop failures even without the volcano.
Do you see Arctic ice then returning to the highs of like 1979 or so?
Definitely. Once we get out of the El Nino, and it actually increased quite a bit last spring even before summer came on in the Arctic. But this is all going to be increasing. We're at the bottom as far as the Arctic and Antarctic ice is. It's going to be replenishing. The North Pacific ocean water temperatures would be cooling down. That would essentially stop any ocean rise out there. The Atlantic Ocean is still warm, very warm. That's a cycle that comes every 70 years. That's to be expected. That's why we have an increase in hurricane landfalls. It's because of the warm water. But that's expected. That started in 2016, and that will run into, about the early 2030s, and then the Atlantic will cool down. And once we get both of them cooled down, that's where in the 2030s, we're really going to hit some nasty, nasty, nasty weather.
Are you familiar with the work of Carl Otto Weiss? And if so, do you kind of agree with what he's talking about with the solar cycles lining up?
Solar cycles line up also. I myself believe that the gravitational cycles are the more important ones. The solar cycles have a hand in it, but not as much as the gravitational cycles.
Everything you've talked about here today so far has been more of short-term stuff in terms of you're not predicting a full-blown ice age where we're going to get 1,000 feet of ice over Chicago anytime soon, or are we?
No, that ice age is a long ways away yet. None of us are going to live to see that. We're talking 20,000 years from now. These are just the 230-year global warming, global cooling cycles. Like I said, we'll start warming up again in about 150 years and then cool down again. And each one will get progressively colder each 230-year cycle. But we were warmer, much warmer, 6,000 to 8,000 years ago. And we've had several cycles in there that come about every 1,800 years or so. And each one has been warmer than the cycle we're in now. We're actually in the coolest cycle, warm cycle, in the past 8,000 years as we're continuing to cool down.
Now, if you had to make a guess about where global average temperature is going to go between now and 2100, and also where global sea level is going to go between now and then, what would you say?
Okay, well, we're going into global cooling. So as I was indicated before, we're going to be cooling down each year now, progressively colder and colder. Some of the Arctic blasts that we get here and in Europe will get longer and longer. It's not just an overnight thing where you're in it. Progressive, this is what happened in global warming. From year 2000 to 2023 or so, each year just progressively got a little warmer, progressively warmer. That's what we're going to see in the global cooling cycle. So by 2030, we're going to be quite cold. It will be a steady cold during the winters. And then 15 to 20 years into the global cooling cycle is going to be our nastiest cold, colder than the 1950s and 60s. And then if we do get the volcano on top of it, then, well, we talked about that. And so you had a second question there on...
Oh, sea level itself between
sea
now
level.
and then? Yeah.
That's very important. I do have a presentation on it. I maybe in one of my videos online. What I'm looking at is, okay, Pacific Ocean is cooling down. The North Pacific is cooling down. As it cools down, the water is going to contract a little bit. So sea level rise is done in the Pacific. That's done. No more sea level rise. In the Atlantic, NOAA is predicting sea level rises of anywhere from 12 to 24 inches from now to 2050. Not going to happen. What's going to happen is we're going to start getting these colder winters. We may get another couple inches of sea level rise, but then global cooling is going to be taking hold more. That will contract the ocean water temperatures, and actually the ocean will start going down a couple inches. And then we'll be in full-fledged global cooling, and everything will even start lowering again as the ice builds up more and more in Greenland and the Arctic. So, no, I'm looking for at maximum 2-inch rise during the next 30 years, and that 2-inch rise will only be during the next couple of years, and then it's going to flatten out and go down.
And do you think we could burn enough fossil fuel if we just burned as much as we can kind of between now and 2100 to make it warm? Or is CO2 such a small factor that even that wouldn't work?
A very small factor is CO2. The rise in CO2 since 1850 to present time is, actually CO2 is only 0.04% of the atmospheric gases. That's 4/100th%. The fossil carbon dioxide is 4/1000th%. That can't do anything. It's been overblown. I call all of this political science. The whole global warming issue is political science. What I present is real science, not political science.
You were at NOAA at some point. Were there a lot of believers there in the whole political science thing that we're overheating the Earth? And do you have any more contacts now? And do you know what's happening there now in terms of number of believers versus non-believers?
Well, one thing I know that people in NOAA and National Weather Service are not allowed to talk about climate change. There was an internal memo sent around about 8 years ago restricting any meteorologists from talking about climate change. Now, the higher-ups that are in the climate issue, I don't know if they believe in it, but they're dictated to do this. It's all of this is really hinged on one aspect that I don't like, and that is the grant money that goes to the universities. And I talked to a couple retired heads of departments, and they confirmed my thought. What happens at a university is you get the grant money, you apply for a grant, and the grants are stated in such a way that you have to, if you get the grant, you have to do or find the outcome that the grant wants. That, okay, human activity is causing, the global warming. So all the grants past 15 years have really been for human cause to global warming, not natural cycles. So the professors told me that it's the grant money. We have to do what the grants are asking for. Now, once a professor retires, then they can do what they want. And I showed you a graphic here earlier on about the rise in carbon dioxide since 1850, Scrabble et al. 3 retired physicists. They had to wait until they retired. And then they put out the paper on the carbon dioxide and that it's 80% natural rise. But they couldn't do it while they worked for a university.
Do you think that scientists are going to continue to have to speak out in favor of it, or they're going to have to toe the line even as the Earth continues to cool? At what point does this break down and people start, speaking about reality instead of trying to get grant money?
Well, I'm hoping to, and a lot of people are trying to get me in contact with people in the government that are conservative, and really none of our politicians really understand climate change. Everyone's been brainwashed. And this is what I've been asking certain people in the government is get me in to teach our representatives, our senators, people in the government. They do not know. Some government officials say that, we have to lower carbon dioxide down to 0. Well, you know what happens on that? Okay, we're 0.04 right now. It fluctuates between 0.025 to 0.04 usually. If you take or extract too much carbon dioxide, bring it down to below 0.02%, our plant life will start dying. You can't have that. We have to have carbon dioxide. It is a nutrient that the plant life has to have. And plants, their byproduct is oxygen. We need that. Our oxygen levels are a lot lower than they used to be. We're becoming oxygen starved. So it's all kinds ties in, really. So what we need to do is find an avenue where we can teach people about the real climate change. Very few people know that the carbon dioxide in the atmosphere is only 0.04%. They all think it's somewhere between 5 to 50%. That's what happens when I have some people that they go out and give talks, and they start the talk just like I do. I say, okay, what percentage of the atmospheric gas is carbon dioxide? And the normal answer is 5% to as much as 70%. There was a great clip that I had, the 2-minute clip from Washington. It was a U.S. representative talking to people in one of the meetings, and he asked that same question: what percent of the atmospheric gases is carbon dioxide? Their answers range from 2% to 8%, and it's 0.04%. So people do not have a clue. They're brainwashed. Carbon dioxide has nothing to do with climate change. It's natural cycles.
Would you be willing to talk to politicians or testify in Congress, et cetera?
Oh, definitely. Definitely. They need a whole course on it. It's what they need. People are not taught this in high school or even in college. The young high school graduates that are going into meteorology in colleges do not even know this. They think carbon dioxide is up high and that it's causing climate change. So this is what we're battling, is the young people are not being taught. And no one's being taught. And we're not allowed to talk about this in newspapers. Most media outlets, thank God for podcasts, great help. And this is what we need: more podcasts, more people like you, Tom, that will get the information out to everyone. And I was hoping the podcast 64 did very well. Great comments. It did well, but I was hoping it would go viral. But I think some people are so brainwashed, they kind of wonder if what I'm talking about is true. But this is what we need, is something to go really viral, and also some cold winters.
Okay, I just checked here. Your podcast number 64, it did get 2,800 hours of watch time, which that makes me happy. I'd like to see it get more, but that's a good start. Yeah,
it was up to 13,600 views, I think. And I'd like to see it up to about somewhere between 1.5 to 13 million.
I would like that too. Very good. All right. Any other points you'd like to make on this podcast?
I do have various talks and videos, but see, I talked about 6 subjects on here, so just briefly on about 6 subjects. So some of mine is just right on one subject, like our podcast number 64. That was totally on the carbon dioxide issue. And so there's a lot to talk about. There's a lot to talk about, definitely. And this is what we need. We need a president and people in Congress that will go in the right direction before it's too late. And we all know, we see in the news what's happening, and if we don't make a change here pretty soon, it's going to be too late to change certain things. We cannot go down this darn rabbit trail of carbon dioxide. We have to get off that and get on to the real subject.
I did put links in the show notes here to your website and to your YouTube channel and your Twitter, so people can follow up there if they would like to.
Okay, thank you, Tom.
All right. So thanks again for doing this, David Dilley, and we will talk to you next time. Thank you.
Okay, bye-bye.